Hello everyone, welcome to the video lecture series of course Internet of Things. In today's lecture, we are going to discuss topic energy, retail management, etc. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have discussed smart lighting introduction, smart lighting simulation using Arduino, smart lighting simulation setup using Arduino, intrusion detection, smart city, security, privacy, and trust in IoT, data platforms for smart cities, risk in smart city IoT platform, smart transportation in smart city, data aggregation for IoT in smart city and security, risk in smart city IoT platform, security. Now let us discuss the topic energy. Energy. It has been analyzed that IoT has a big role to play in energy supply, consumption, and infrastructure. Renewable energy needs greater monitoring and control comparing to conventional fossil resources. Power plants in future needs to be smart, intelligent, secure, and controlled. Virtual power plants can be formed to have efficient distribution and management of energy. Ability of this IoT-enabled grid is characterized by variable supply of power, reaction to fluctuation in varying demand, and reconfiguration without taking the power source down. There are many challenges, however, in the implementation of IoT-enabled power grid. Integration of heterogeneous power supply units, integration of cyber physical system in the existing infrastructure of power grids are the major challenges. The entire infrastructure of building smart grid system includes formation of efficient transmission paths for energy from the sources to the end user. Moreover, the channel of control information communication needs to be extremely secure and private. The smart grid can exist much similar to the computer network or internet, both in the terms of routing and data management. It raises the concept of Internet of Energy. The flow of energy will get governed by standard protocols. Gateways and routers will be deployed like an internet for control flow. The futuristic concept of IoE, that is Internet of Energy, includes the smart power distribution, grid monitoring, on-demand power supply, self-healing capability. The suitable proposed architecture can be presented by students as an assignment for the IoT application. Retail management. Retail management. IoT has become a dominating force in the field of product placement in the real world. Easy access to all the retail product via mobile app and its real-time tracking and scheduling makes the work of stakeholders and the customers very efficient. IoT can connect back to two basic concepts. First is internet-oriented development, that is moving from desktop-based machine to handheld devices. Secondly, thing-oriented development that refer to identification of all individual items in retailing with respect to its information. This is achieved via RFIDs, barcodes, etc. These two concepts offer an opportunity to incorporate retail industry with social media via internet and reach out to large crowd. This allows retailers to gain an insight to users and know customers' feedback and new requirements which helps them to better their marketing. Retail industries with low margin and high revenue use information system to improvise their strategies. But with the rise in technology and online shopping sites, retail business is in danger of becoming just showrooms for online retailers. So, with the help of IoT, retailers can provide a fluent flow to the customers right from goods identification to payment. RFIDs and barcode scanner can help in product identification and bill generation scenarios. RFIDs can also be used for the facility of payment method if connected with the credit debit cards. With customers' feedback, retail industry can innovate with the help of IoT to gain an edge over online retailing. Now let us discuss the logistics. Logistics have several application areas where IoT can significantly contribute. Route generation and scheduling, fleet tracking, shipment monitoring, and remote vehicle diagnostics are few of them. Route generation and scheduling. Logistics these days are heavily dependent on technology. Data collected from various resources are used to determine the route and scheduling for transfer of good and mobile services. Route guidance, dynamic vehicle routing is enabled by the combination of GPS and other smart navigation systems. Source to destination optimized route can be generated by such smart systems containing multiple legs once the proper requirement and traffic information fed into the system. Fleet tracking. Real-time location of the vehicle fleet can be tracked using GPS and smart navigation system. This can be used to track the vehicle fleet, train status, aeroplanes and other vehicles. Fleet tracking system can be enhanced to include cloud and more smart system to control entire fleet of vehicles. Deviation from the predefined route can be tracked and altered at the base station by these kinds of systems. Shipment monitoring. In many scenarios of the transportation system, there is a need to keep track of the shipment inside container vehicles. Monitoring scenarios are equipped inside the containers. They can continuously track the shipment condition and can send the update status timely at base station. This particularly useful for food products where advanced biosensors are used to keep track of the freshness of the food. Now let us discuss the agriculture. Agriculture smart irrigation system. The primary objective of smart irrigation system is to develop an IoT system which can collect data related to soil condition and can automate the process irrigation, that is amount of water flow. This system is intended to detect moisture level in soil using the required sensors and control the amount of water to be used for irrigation using automated valves. In general, when the moisture level goes below a redefined or configurable threshold value, it releases the flow of water. This system may include many kind of sensors for monitoring soils and air moisture conditions. This sensor act as a multiple end nodes of data collection for the IoT system. Data required for smart irrigation from historical records and incidents can also be collected from cloud and can be analyzed for scheduling of irrigation. The data is collected by the local embedded system which is connected with the sensor directly or indirectly. The local system can apply some pre-processing on the collected data. It can apply certain rules under which data need to be validated and qualified to be stored. REST communication API can be used to transfer the data to the cloud application. Cloud application on receiving of data can further filter the data for different applications like irrigation scheduling, water release and control system, etc. Cloud can publish and store the soil moisture and weather related data for different potential candidates. Register subscriber clients app can get the soil moisture condition, irrigation schedule. The process specification diagram for the irrigation system is shown in the figure. The figure shows the process specification diagram for smart irrigation system. The possible deployment diagram of the smart irrigation system is shown in the figure below. The figure shows the deployment diagram of smart irrigation system. The end nodes in local system domain at different locations can be mini computer like BeagleBone Black or Raspberry Pi, and sensor could be soil moisture sensor. The nodes are the sensor that soil moisture data and send it to the locally connected embedded system. Required processing is applied and data is transferred to the cloud using REST API. Cloud service distributed the moisture related information to register subscriber. Water releasing system checks the threshold value, release the water accordingly. Weather monitoring for agriculture. The primary objective of weather monitoring system is to develop an IoT system which can collect data from different environmental and weather conditions. This system may include many kind of sensor for monitoring different weather conditions like the temperature sensor, humidity sensor, pressure sensor, moisture sensor, light sensor, etc. These sensors act as a multiple end nodes of data collection for the IoT system. The data is collected by the local embedded system which is connected with the sensor directly or indirectly. The local system can apply some pre-processing on the collected data. It can apply certain rules under which data need to be validated and qualified. REST communication API can be used to transfer the data to the cloud application. Cloud application on receiving of data can further filter the data for different application area. Cloud can publish the weather data for different potential candidates, register subscriber, clients and apps can get the weather information as they require it. The process specification diagram for the weather monitoring system is shown in figure. Figure shows the process specification diagram for weather monitoring system. The possible deployment diagram of the weather monitoring system is shown in figure below. Figure shows the process specification diagram for weather monitoring system. The nodes are the sensor that collects weather condition data and send it to the locally connected embedded system. Required pre-processing is applied and data is transferred to the cloud using REST API. Cloud service distributed the weather information to register subscriber. Now let us discuss the health and lifestyle. Health and lifestyle. Similar to home automation, health is a famous in medical soul. This case study defines a large range of productivities for hospitals, doctors, and most importantly for the patients. Patient surveillance. Monitoring conditions of patients like heart rate, blood pressure, sugar level, etc. is very helpful for doctors to effectively treat the patients. Medication reminders. Timely reminders to the patients and nurses about the medication and dose are provided so that the patient receive treatment in timely manner. Medical fridges for storage of vaccine, medicines and any other organic medical material in its habitat temperature is maintained by IoT embedded fridge by controlling condition inside the fridge. Fall detection. This is very helpful for elderly and disabled person to move freely. This detects and informs the user for any falling situation. Sportsman care. Continuous monitoring of vitals of sportsmen can be used for improving their performance in the field. Ultraviolet radiations. This type of sensor can be used to detect the excess of UV radiation to prevent the users from getting exposed to UV rays for long hours. Now let us discuss the industrial IoT. Industrial IoT. Internet of Things, that is IoT, can be defined as the inner network of devices that have unique identities. Communication between these devices, collection of data, processing of such data to obtain the result in the main focus of the IoT. In consideration of industries, IoT application will try to cope up to the manufacturing process and will try to improve it further. It will seek to adjust to the existing production plant in consideration of operation and interaction, construct new services for development and supervision of industrial installation. Successful implementation of IoT in industries will lead to enhanced infrastructure, lesser operational costs, low energy consumption, and most importantly, higher human safety in factory areas. Value creation and benefits of industrial IoT. Estimation of expected values for the industry need to be established and constantly re-evaluated and attested during the operation. It is usually very hard to define the values and benefits of IoT application and IoT projects at the initial stages of the project because of the several reasons. Values and benefits of IoT projects build up gradually with new IoT implementation in factory projects and grows over time. The value is often hard to measure because of the many multifaceted process and multiple intermediate IoT appliances. Judgment of the IoT in industry from stakeholders' point of view will be this presence of value and benefits of IoT interaction. Value creation will be judged by the owners in the prospects of innovation, productivity, logistic efficiency, and asset utilization. Considering IoT in industries, values and benefits will be recognized in following format. Human safety is hard industrial environment condition with the help of IoT. Location tracking and identification of industry object. Authentic information collection and processing. Reduce production cost and reduce losses. Reduce energy consumption. Innovative process manufacturing due to IoT applications. Innovative maintenance practices and increased lifetime. How well connected are these industrial smart objects? How well can the industrial practice can be maintained with the help of IoT? Improve industrial production cycles and life cycle flow. Challenges faced by IoT industry applications. With reference to the above requirements, implementation faces several challenges in achieving these requirements. There are many challenges in IoT development and can be distributed in vast categories, but considering the scope of topic, it can be mainly divided into four groups. Technical issues in IoT devices, energy consumptions and lifetime issues, data collection and information gathering challenges, and business and human problems. Technical challenges in IoT devices. One basic challenge is packaging. Proper packaging is very important for reliability of devices. Depending on the industrial application for application feature requirement may vary, like high sensing capabilities for sensors with high sampling rate, speeder communication and wireless data transfer. Highly synchronized data collection in both single hop and multi-hop networks in industry. Temporarily attached IoT devices like that of ad hoc device have to be easily configurable and can be reused. Diversity in IoT devices is one of the major problems in this. In industries, variety of combinations are encountered like wireless and wired technology. In industry uses different frequency band, active and passive RFID readers with and without sensing. Such issue causes interaction difficulties while communication fails. Energy consumption and life cycle challenges. The normal lifespan of industrial appliances is normally greater than that of the average IoT device. This issue needs to be considered while designing, installation and in management of the industrial process practice so as to cope up with the replacement of worn out of IoT devices. Energy consumption is also an issue for IoT devices for industrial areas. Eco-power energy harvesting can be the solution for this based on the application requirements. Data and information challenges. IoT implementation for industrial system requires large amount of data handling that needs to be successfully collected from hundreds, sometimes even thousands of sensors spread over a large geographical area. For example, consider an industry having 100 supervisory sensors installed that collects one temperature reading per minute, one audio channel with 50K samples per second. In such example, raw data collected within a year may lead up to the 4 to 4.5 PB, which is huge. This huge data collected needs to be processed into information with the help of adaptive data handling, processing and fusion techniques. Also, this data need to be associated with already in place automation techniques so as to control data for in place industries. Along with the processing, this data also need to be secured from any of the cyber threats. Business and human challenges. One of the major challenges in IoT development for current industry trend and future factory setup is human well-being and felicitation. Day by day, the productivity requirement in the industry is increasing along with the quality and the cost, and human resources in comparison is aging faster and facing lack of skill sets. IoT can provide a platform to industries that will enable the available network force to reduce their work efforts and reduce search time for data and information they are looking for. Merging IoT applications with already in place producing and running industries may cause shortcoming in the existing plants. IoT technologies that are going to be implemented in existing industry and future factories require a complex blend of skill by the person employed on site. As the skill set and workforce is also important in IT and IoT mix with the industry, a challenge is to unite human IT and IoT resources. Now let us discuss the IoT design ethics. IoT design ethics. Ethical design of IoT application is very important aspect of system design for Internet of Things. Many sensitive issues are associated with complex IoT applications like data privacy, security, risk of failure, etc. Many governing bodies are currently working and addressing the different sensitive issues associated with IoT applications. EU in Europe has come up with the new strict regulation in data privacy for Internet of Things application. They have set regulation for both IoT service buyer and the providers. The aim is to protect the personal data of individual at any cost. This leads to a clear definition of personal data. An ethical design of IoT can help in managing all these sensitive issues properly. Latest technology, awareness, best practices, discipline designing and awareness, all aspects of the developers contribute in ethical designing of the IoT product and the services. Many IoT agencies regulating bodies have proposed to develop a parallel smart system for each IoT application to monitor the goodness of IoT service in terms of ethical design. This system can play its role starting from the design of IoT products and service to the deployment of system. Despite of having significant attention on the ethical designing of IoT applications, there are associated challenges in ensuring the product is ethically designed. Major challenges are economic incentives for data protection, incomplete information about the consequences of data leaked or disclosure, psychological biases, too much information attached to about the consequences of data breach, uh, conformance to regulatory framework. Now IoT in environmental protection. IoT in environmental protection, that is air pollution monitoring. The primary objective of air pollution monitoring system is to develop an IoT system which can collect data from different environmental conditions and provide information about the air pollution. The system design and step of implementation is quite similar weather monitoring system. The application and subscriber of IoT may differ. This system is intended to detect harmful gases emitted by factories, vehicles, and other sources. This system may include many kinds of sensors for monitoring different environmental conditions and gases. The sensors in such IoT system mainly belongs to the category of gaseous and meteorological sensors. These sensors act as a multiple end nodes of data collection for the IoT system. The system design and development design of the pollution monitoring sensors are almost similar to weather monitoring system that we had discussed in previous case study. Only few additional gaseous and meteorological sensors added to the system. The IoT system consists of multiple nodes located in different pollution probable areas, conditions and locations. These sensors can be CO and NO2 sensors. The data is collected by the local embedded system which is connected with the sensor directly or indirectly. The local system can apply some pre-processing on the collected data, apply certain rules under which data need to be validated and qualified to be stored. REST communication API can be used to transfer the data to the cloud application. Cloud application on receiving of the data can further filter the data for different application area, geographical location and pollution sources. Cloud can publish the weather, pollution and data for different potential candidates, registered subscriber, client, Apps can get the weather and pollution related information as they require it. The process specification diagram for the monitoring system is shown in figure. Figure shows the process specification diagram for pollution monitoring system. The possible deployment diagram of the pollution monitoring system is shown in figure. The figure shows the deployment diagram for pollution monitoring system. The end nodes in local and the local domain at different locations can be a minimum computer like a mini computer like a BeagleBone, Black or Raspberry Pi, and sensor could be MICS 2710NO2 and MICS 5525 CO sensor. The nodes are the sensor that collects pollution condition data and send it to the locally connected embedded system. Required pre-processing is applied and data is transferred to the cloud using REST API. Cloud service distributed the pollution related information to registered subscriber. Summary of today's lecture. Today we discuss energy, retail management, logistics, agriculture, health and lifestyle, industrial IoT, IoT design ethics, IoT in environmental protection. Thank you.